So another video of statistics and probability. We're going to go over conditional probability today. So it says, probably seen this before, probability of A given B means probability of event A occurring given that event B has occurred. So what we're saying is this is we're trying to find a probability of A, but we know probability has C. Given B equals probability of A and probability of B divided by probability of B. So this is what this will look like. This is what we're going to be using, and you kind of might have see the resemblance when we're doing multiplication rule when events are dependent, right? Because you could just multiply the probability of B on both sides out and get probability of A and B together, but that's not for this video. But just in case you guys were wondering, yes, we could make some kind of modifications given the specific parameters to give us what we need. So let's do an example on how to use this. Right, so what we're going to say is, let's just do what we've been doing before, some playing cards, right? Find a probability a king given you got a black card. So like we said before, right, let's write down the givens. We had said there's 13 diamonds, hearts, spades, clovers. We have 12 face cards. We had 26 red cards, and we had 26 black cards. Right, so now this is the given parameters of just center deck of 52 cards. And so we're trying to make sense of the problem. So anything that comes before the word given is going to be represented by the event A. Anything that comes after the word given is going to be considered event B. So that's how we're going to attack this problem. So we're going to say that let event A equal king and event B equal black. So when I write it into this form, I'm going to have P of king given black equals, and so I have A and B. So what I want to do is I want to find what is the probability of A and B, and I want to find just the probability of B. So when I say A and B, this is going to give me king and black. And so I need to find what is the probability of getting the king and the black card together. So going back to what we had said before, that diamond and hearts are usually red hearts, and clovers are actually black hearts. So then, in that case, there's only one king for diamond, one king for heart, one king for spade, one king for clover. And since I want this to find the cards are specifically black and kings, this has one king card, this has one king card. So in total, I actually only have 2 king cards in total that are black. So when I find probability of A and B, which is a king and black, there's actually only 2. And then for black cards, how many black cards in total do we have? Well, let's go back to our list and we say, 26. So we don't even have to think about it. It's right there. So in total, when I do my king and black, I have my formula set up for me where the probability of A and B is in the numerator and the probability of B is in the denominator. So in that case, I have 2 divided by 26. And that is my probability of getting a king or a black card. Or excuse me, probably getting a king given that I got a black card in my first try. Okay, so it's not too bad. Pretty straightforward. So let's do another example that's quite similar. But now let's change it up a little bit. Instead of having face cards, let's do a soup and see what we get. So I need this. I don't need this. I don't need a king. I don't need a black card. And let's do this. Somebody has suggested before that what if we were to want to find 10, given that you got a diamond. So now let's do numbers and groups. Same thing. This doesn't change. Our givens doesn't change, right? Since we're still dealing with conditional probabilities, because the problem still says find a probability of getting a 10 given that you got a diamond. So once again, the key word in this case is given. Since we're dealing with given, right, we have a conditional probability and we have a formula that we want to follow. So that's essentially the essential idea of this whole situation, is just trying to follow this as best as we can. So we're going to once again let A equals whatever is before given. So in this case, it's 10. Anything that comes after given will be represented by event B, but in event B in this case equals to diamond. So then we're trying to find the probability of A and B. So A and B in this case is a 10 and diamond. So the probability of A and B is a probability of 10 and diamond. So we're trying to find how many times does this occur inside a standard deck that we actually do get a number 10 and a diamond being exactly at the same time. So as we said before, there's 13 diamonds, 13 hearts, 13 spades, 13 clovers. So specifically, we're only looking at diamonds. And as when I look at my diamond cards, it goes from 2 to 10, then it has a king, has a queen, has a jack, and then has an ace. So in this case, I notice that there's only one instance in which my deck is actually a 10 and the diamond exactly at the same time. Therefore, when I say the probability of 10 and a diamond, there's only one actual case that we get that scenario. So then that guy is done. Now I look under event B. So we said event B is diamond. So what the probability of B, which equals probability of a diamond. So the probability of a diamond, we said was, well, we actually do have 13 of each. So how many diamonds do we have in total? In this case, we actually have 13 diamonds. And so now that I know the probability of getting A and B, which is a 10 and a diamond, which is 1, and the probability of B, which is the probability of the diamond, is 13. Now, do I have enough to be able to plug into my formula? Yes. So essentially, the ideal is the solution is going to be the probability of, we said was A is a 10, given diamond equals 1 divided by 13. And that is our solution. Nothing too hard, nothing too complicated. The essential idea of conditional probability is just to define what is event A, what is event B, right? And we want to be able to do that because it's going to come in a formula where we said event B is always going to be the event that comes after we're given. So then when we find the formula, all we're trying to do is, when do we have any kind of inclusive events going on together? So when A and B are occurring exactly at the same time, divided by probability B, because we're looking for specifically everything that's occurring in probability of event A. So this is just simple idea, simple skit of conditional probability with playing cards. So thank you guys for listening.